This is a weekly summary of interesting news that is relevant for my lectures at the Eastern University of Applied Sciences in Switzerland. My name is Thomas Boczek, and today we will discuss 5 topics. The first 2 topics are about self-hosting, and this is an interesting exercise to orchestrate, install, and maintain multiple services yourself. Both self-hosting articles are about email self-hosting, which I do as well. So the first article is the following here. It's a series of Mastodon tweets, is about self-hosted email server and to challenge the common belief that running your own mail server is impossible in 2025. I'm not sure why or if this is a common belief. So the email server was moved from DigitalOcean to Hetzner Cloud and switched from a manual Debian setup to Nixos with modern tools like RSpamD. The key technical requirement they met were clean IP reputation. This is quite important for a mail server, SPF, DKIM, and DMARC configuration. And with these in place, Gmail accepted their emails without issues, though Microsoft 365 continued to reject them regardless of proper configuration. I also self-host my email on Hetzner and haven't had problems with Microsoft 365, so experiences may vary. And the integration took about a day and resulted in a working configuration in under 500 lines of Nix configuration. Graylisting combined with basic checks like rejecting malformed hello hostname and clients that pipeline data incorrectly reduced spam from 50 messages per day to nearly 0. And in my setup, I also use graylisting and I also have these hello checks, but I'm not running RSpamD yet. And this lets through about 18 spam messages per day, but with Thunderbird's chunk recognition on the client side, where the chunk folder keeps messages for 14 days, only about 1 spam message per day makes it through. The author argues the myth persists not because self-hosting email is impossible, but because the software stack is all poorly documented and hard to configure correctly. However, using declarative configuration tools like Nixos can handle much of this complexity. And I never tried Nixos since I did not think that configuration is that hard, especially with large language models. Config options can be explained, which I'm using a lot. And here she mentions also that you need to have a PhD in bullshit to correctly configure it. I have to say I do have a PhD, and I'm not sure what field she's referring to, but apparently I have the right kind of PhD for this. Now, why do I think self-hosting is great? Well, to keep exercising the orchestration of services, since I'm also teaching this, and otherwise it would be just theory, and the best way to understand something is by implementing or actually running it. The next article is also about self-hosting. It's the following article here. It's self-hosting email like it's 1984. And here the approach is even more minimal than the previous example. And here they skipped multi-user webmail entirely and avoided setting up POP3 or IMAP with Dovecot. Instead, they SSH into their mail server and use command line tools like Snail or MailX to rate and send emails directly. He also mentioned here this warning: with self-hosting, you risk not receiving mail or someone missing your mail. On the other hand, this could happen with big providers as well. If you self-host, you have to a certain degree the possibility to investigate. And the setup in this article only requires Postfix as the SMTP server and OpenDKIM for proper email authentication. For TLS encryption, they only need one SSL certificate for their MX hostname, not separate certificates for each email domain, because TLS only secures the connection between mail servers, not the actual email addresses used. They configure DKIM, SPF, and DMARC through DNS text records to prove their emails come from their domain. Their ISP set up reverse DNS the next day after a simple request, which improved their reputation score. They tested the mail server with the mail tester and got a perfect 10 out of 10 score. Emails to Gmail, GMX, and Outlook were delivered successfully without being marked as spam, and the entire setup took only a few hours. The author chose the title self-hosting email like it's 1984, since it's using the command line, or he's using the command line to access his email. So if using command line email is like it's 1984, then using Thunderbird would be like emailing from 2004 when it was first released. So I guess since I'm still using Thunderbird, I could call myself progressive. The next article is about consistent hashing. It's the following article here. This is a detailed explanation of consistent hashing, an algorithm used in distributed systems to minimize disruption when adding or removing servers. The core problem is with naive hashing, when you calculate which server handles a request using just a modulo arithmetic like hash modulo n, changing n means almost all items gets reassigned to different servers. And the author demonstrates this with actual code, showing that when going from 32 to 33 nodes, all three test items completely change their assignment. That means we would need to move a lot of data between the nodes. And consistent hashing solves this by mapping both servers and items onto a circle here. In my lecture, I also show a circle for better visualization, but it can also be a tree like in Kademlia, which also has some nice properties. And each item is assigned to the nearest server in a clockwise direction. And when a server is added or removed, only items near that position needs reassignment. With m items and n servers, only about m divided by n items change their mapping compared to all m items with naive hashing. And this property is called monotonicity in the original paper. And well, another way to look at this is that nodes have responsibilities, and when more nodes join, the responsibility range shrinks. So data outside the responsibility range, they have to be moved around. I did not follow up on all the details of his implementation, but it seems that the author is also learning by implementing it, and I really like this approach. I also talk about consistent hashing and DHTs in my distributed systems lecture, and there we also try to avoid moving data across networks, and this is what makes consistent hashing great. The next article is about the AT protocol. It's the following article here. This is a detailed explanation of how the AT protocol resolves URIs, which is the addressing system used by Blue Sky and other applications using the AT protocol. The key insight is that the AT protocol flips traditional URI structure by putting the user in the authority position instead of the hosting provider. In a normal HTTPS URL, the authority is the server hosting the data. In the AT protocol, the authority is whoever created the data, and the actual hosting location is discovered through a resolution process as shown here. It's actually flipped. So this is HTTPS, and here down we have the AT protocol. Now, resolving an AT URI happens in 3 steps. First, resolve the handle to an identity called DID. You do this by querying DNS text record or making HTTPS requests to well-known endpoints. Second, resolve that identity to actual hosting by fetching the DID document, which is like a passport containing the current handle, a public key for verification, and most importantly, the service endpoint where the data is actually stored. Third, request the JSON from that hosting server using the getRecord endpoint. And there are two DID methods supported. The DID web method ties your identity to a domain you control, which means you may lose your identity if you lose the domain. The DID PLC method uses a centralized registry called PLC directory, which protects you from losing domain control but introduces dependency on whoever operates that registry. Each DID document includes three critical pieces, also known as field for the current handle, public key multibase for cryptographic verification, and the service endpoint for actually hosting the locations. So this is the JSON actually, and here we see the also known as, here we see the public key multibase, and here we see the service endpoints, and this is quite crucial. And the author demonstrates this by walking through actual curl commands to resolve real URI step by step. The design allows users to change their handle or move their hosting without breaking links because apps store the permanent DID form rather than the fragile handle form. All records are cryptographically signed, and the hash chain prevents the registry from tampering with history. And this shows how identity and content addressing can be done in a distributed system. The three-layer resolution from handle to identity to hosting is similar how DNS works, but adds portability. Trade-off between DID Web and DID PLC shows the classic distributed system tension between decentralization and convenience. And actually, I'm thinking for the next distributed systems lecture in the challenge task, maybe we may use the add protocol and make it mandatory. The last article, it's the following one here. So there was a fire that destroyed a data center, a fire at the South Korean's national data center, destroyed the government's cloud storage system permanently, erasing work files from approximately 750,000 civil servants. The government drive system had been mandatory since 2018, requiring government officials to store all work documents in the cloud with about 30 gigabytes of storage per person. The fire damaged 96 critical government information systems, and the critical failure was also here the backup strategy. Due to the system's large capacity and low performance storage structure, no external backups were maintained. While most systems at the data center were backed up daily to separate equipment within the same center and to a physically remote backup facility, the government's drive architecture did not allow for external backups. This means all data was permanently lost, and the Ministry of Personnel Management, which mandated exclusive use of government drive, was hit hardest. Some data may be recoverable from other systems which stored official documents created through formal reporting processes and from any files saved locally on personal computers within the past month. And this demonstrates a fundamental failure to follow basic backup principles. The industry standard is the 3-2-1 backup strategy. Keep 3 copies of your data, store them on 2 different types of media, and keep 1 copy offsite. In this case, the government had 1 copy on 1 type of media in 1 location. And when the fire hit, everything was gone. The excuse that the storage structure did not allow for external backups is actually nonsense, because any data that can be stored can also be backed up. And I think this was a cost-cutting decision that backfired catastrophically. So this shows why redundancy and fault tolerance are not optional in distributed systems. Hardware will fail eventually. The question is not if, but when. The 3-to-1 strategy protects against local disasters like fire, hardware failures, and ransomware attacks. Having backups in the same building defeats the purpose, as this incident proves. Proper distributed systems design assume failure and plans for it. So that's it for this week, and this is a friendly reminder to check your backup strategy.